So this video is going to go over atomic size and the trend that we see. And so we're going to do atomic size according to group, so going down a group and then going across a period. So for this discussion, please note we had already talked about the Bohr model to kind of use that as our way of visualizing something we can't quite see. So let's take a look at lithium. Lithium has 3 electrons, so it has 2 in the first energy level and 1 in the second energy level. It has an atomic size of 156 picometers. Sodium has 2 in the first energy level, 8 in the second energy, and 1 in the third, with a total of 11 electrons at 186 picometers. And then potassium has a total of 19. So it has its last electron in the fourth energy level. It has a 231 picometers. So we're going to use this model, even though the Bohr model is incorrect, to kind of visualize what we mean by atomic size. So again, we're taking the distance, say from the nucleus to the outermost energy level. So we're going to use this as our model. So atomic size down a group, okay, is increasing from top to bottom, okay? So the evidence we are going to be using is always going to be the graphs that you guys did or off the periodic table. So remember, the Flynn periodic table does have atomic size on it, what I call the back side of it. So when you look at it, it is the atomic radius in picometers. So you could easily use quantitative data for this to say who is larger and compare those numbers. So the focus is not going to be on the evidence this time. It's going to be on what we call the reasoning portion, So the reasoning portion is, you are adding protons, and you could also put electrons there, and energy levels. So since you keep adding energy levels with the electrons and those protons in the middle, you need to use the Bohr model to kind of show how you get more and more energy levels, okay? So as you go down a group, you're going to see that happening. So we are going to be using, again, the Bohr model to kind of give us some explanation. But for the questions you're going to see on assessments, sometimes you're just going to be asked to compare and say who is bigger. So in this case, I have calcium or barium. So again, take a look at where it is on the periodic table and see if you could take a guess. So pause the video and see if you could take a guess as who's going to be bigger. So barium is going to be bigger. Again, you're going to get a point for getting it correct, but then you're going to have to explain why. So with this one, because of calcium and barium and where they are on the periodic table, it's hard to draw a bunch of circles. So instead, we're going to write something like this. So the max energy level for calcium is energy level 4. So energy level 4, while barium is energy level 6. So because this has more energy levels associated with it, it is going to be the bigger atom. So again, the trend is as you go down, you get an increase in size. So the one that is the most confusing is the one where you go across the period. So again, across a period is from left to right on the periodic table. A period is a row on the periodic table. A group is a column on the periodic table. So again, looking at data, it's pretty easy to see exactly what is taking place with the size. So again, graphing the data, you could see as you go across the group, you see that the numbers get smaller. So again, you could use a graph, you could use data from the Flynn periodic table to essentially figure out which one is bigger. But this one is going to require more discussion on the reasoning part, because the reasoning part is probably the trickiest out of all of this. So in your notes, write lithium and beryllium, and draw their Bohr models, okay? So lithium would have 3 electrons, boron would have 4 electrons. So I have 2 electrons in the first energy level and 1 in the second energy level, and beryllium is the same, except it has 2 in the second energy level. And again, the 156 and the 111 are picometers. So those are actual atomic size numbers off the periodic table. But please understand that lithium has 3 protons and beryllium has 4 protons. So what we have to think about is Coulomb's law in this case. Since they both have the same number of energy levels, there has to be something else that is going to change between the two of them, because we have data, 156 to 111, it is getting smaller. So here's the theory. The theory is Coulomb's law. The protons that are in that nucleus, every time you keep adding another electron, you're adding it to the same energy level. So the proton and the electron is not really changing distance, but the proton is so much bigger than the electron. You could say in terms of magnets, if that's a way you want to think about it, the protons can then pull in a little bit every time you add an electron, and so it gets slightly smaller as you go from left to right. So this one is probably the trickiest of all of the trends, but it does explain ionization energy and electronegativity very nicely. So if you want to copy this down in your notes, so you're adding protons as well as electrons in the same energy level. Because protons pull on the electrons, and you're going to use Coulomb's law as your rationale there, protons, again, being positive, are going to pull in on those negative electrons. And so it's going to make the atom slightly smaller. And again, we're talking picometers here, but they are getting smaller. I mean, the numbers are going to get, and as you go from left to right in certain parts of the periodic table, you will see some blips or exceptions. Again, we're not going to test you on exceptions. This is what we call a general trend that you see. So again, if I give you phosphorus or if I give you chlorine, which one is going to be bigger? Okay, so what you want to do is look at your periodic table and say, okay, here's phosphorus and here is chlorine. So the one that is bigger is the one that is furthest to the left. So that would be phosphorus. So again, you would have to use some explanation saying phosphorus has the same energy level as chlorine. So they are both energy level 3, okay, energy level 3, but chlorine has 17 protons and phosphorus only has 15 protons. So that is why you would say chlorine is going to be slightly smaller, because of the fact it has more protons to pull on those electrons in the same energy state. So that is what we call atomic size. That's what we call atomic size. So going down, it gets bigger. From left to right, it gets smaller.